Hey everybody, my name is Brennan Beam and I'm a hydraulic engineer at HEC, and in this video I'm going to talk about the necessary data for an FIA study. We can all breathe a sigh of relief that most of the data we enter into FIA is going to be geospatial. It's not the same table interface that FDA has. Our structure inventory, our agricultural inventory, the hydraulics can all be entered in a geospatial format. The kind of data you have determines the analysis you have access to do. Or another way of putting it would be you only need certain types of data if you're only going to do certain types of analyses. So for an agricultural damages compute, you need agricultural inventory. So you need to know where your crops are, data about the crops, how they respond to flooding, and unsteady hydraulics. That part's important, and we're going to talk about that in the next slides. Some kinds of computes need unsteady hydraulics and some are okay with steady, and I'll explain what those words mean. If you're going to do life loss estimation, you're also going to need unsteady hydraulics, and you're going to need a structure inventory with population data. And getting that population data is not always straightforward, but there is a resource available to the Corps of Engineers that can help with that. We'll talk about that later as well. If you're doing just the basic compute, so a direct damage compute, all you really need is steady hydraulics and a structure inventory. So what are steady hydraulics? Steady state hydraulics answers the question, what would our system look like if the flow was X, or 1000 in this case? You can see in my hydrograph up in the top left, the hydrograph starts at 1000, ends at 1000. There's really no sense of timing with this. That no sense of timing is a problem for the computes that require timing as a variable. So agricultural computes use timing in duration. The duration of flooding impacts the response of the crops. In life loss, that sense of timing is important for warning time and ultimately the time people have to evacuate before the flood hits their homes. Unsteady hydraulics is the exact opposite. We have that timing. We see the river rise and fall. We can see from the hydrograph here that it does start down low. It's going to go back up, peak, and come back down. This is what would our system look like during the event. This is the kind of hydraulic data we need to do agricultural and life loss computes. So the other kind of big input that most studies are going to need is the structure inventory. Your structure inventory is very similar to the one you use in FDA. It contains structure values, occupancy type. So then, and just like in FDA, this is where we store the depth percent damage relationships by occupancy type, construction type, to be used to check stability, to see if the structure's collapsed during a compute. Also foundation height, population data, and more. There's a lot of information that we store in the structure inventory. And for USACE employees, we have access to the National Structure Inventory, which is a database of structure data that's been compiled from a whole bunch of different sources. Starting with FEMA has this data, census data for population, and all sorts of places to create what is a really good starting point for any structure inventory for a study. It has population data for day and night for every structure. It's really worth looking into. And if you're interested for your study, you can access it through the model library. I've put the link on this slide. If you've never used it before, new users need to log in with their CAT credentials and then email one of those people listed in the bottom of the slide, and we will get you access. Finally, the agricultural inventory stores all the data we need for an agricultural compute in the same way that the structural inventory stores all the data we need for a structure damage compute. Inside the agricultural inventory, we have a lot of information, the key component really being that crop loss relationship. It's a percent loss over so many days flooding. This is akin to the structure inventory's depth percent damage relationship. So agricultural damages are based heavily on how long the flooding lasts and at what point in the planting cycle that flooding begins. The data for all this can be found in the NASS cropland data layer with more information available at the USDA National Institute of Food and Agriculture. If you have any questions, feel free to ask me directly through an email, or please post your question to the discourse discussion board.